Hello guys, welcome back to my YouTube channel. I am Chandan Kumar KV studying in Sri Venkateshwara College of Engineering wearing the USN 1VE21EC018. Today I am going to introduce you to the types of antennas. Antenna are the essential components of the wireless communication system, acting as an interface between the electromagnetic waves and the electrical signals. They convert the electrical energy into the radio waves and vice versa, enabling the transmission and reception of information over a long distance. The types of antennas are used in the system is crucial for determining its performance and efficiency. Let us see the types of antennas. First comes the dipole antenna. Dipole antenna. Characteristics. A dipole antenna is a fundamental antenna type consisting of two straight conductors of equal length, typically aligned in a straight line and spaced apart by a small gap. It resonates at a specific frequency determining by its length and the speed of light. Operations of the antenna. When a radio frequency signal is applied to the dipole, the current flowing through the conductors creates an oscillating electromagnetic field that radiates outwards as a radio wave. The radiation pattern of the antenna is generally omnidirectional in a horizontal plane and has an H shape in a vertical plane. Advantages of these dipole antennas. Dipole antenna offers several advantages, including their simple construction, relative wideband, and predictable radiation characteristic. They also efficiently transmits and receives the radio signals over a wide range of frequencies. Next comes the monopole antenna. Single conductor. A monopole antenna consists of a single conductor, typically a vertical rod or a wire, mounted over a ground plane. What is a ground plane? A ground plane acts as a reflector and helps to direct the radiated signal in a specific direction. There are some applications about these monopole antennas. Monopole antennas are widely used in the mobile communication devices such as the cell phones and as well as the radio frequency identification system and wireless local area networks. Advantages of these antennas are they are compact, efficient, and relatively inexpensive and manufactured, making them ideal for portable communications. Patch antenna. Microstrip technology. In these antennas, we can see the patch antennas are commonly fabricated using the microstrips technology, where a thin metallic patch is printed on a dielectric substrate which is then placed above a ground plane. Resonant frequency. A resonant frequency of the antenna depends on the size and shape of the patch, as well as the direct properties of the substrate. Advantages. Patches antenna offers several advantages, including their small size, low profit, and with printed circuit boards fabrication techniques. Applications of these are they are widely used in mobile phones, GPS receivers, satellite communications, and wireless sensor networks. Yogi Uda antenna. Driven element. A Yogi Udan antenna consists of a driven element which is a dipole antenna that is directly connected to the transmission line. This element receives or transmits the radio signals. Directors. The directors are several short elements placed in front of a driven element. They are spaced apart at a specific distance and helps to focus the radiated signal in a desired direction. Reflector. A reflector, which is a long element placed between the driven element, reflects the radio signals, further enhancing the directionality of the antenna. Parabolic reflector antenna. Satellite communication. They are used in satellite communication and high gains. For parabolic reflector antenna are commonly used in the satellite communication system, where they are used to transmit and receive the signal over a long distance. They are also used in the terrestrial microwave links. High gain. Parabolic reflectors provide high gain, meaning they are concentrated the radio signals in a narrow beam, which allows for efficient transmission and reception over a long distance. Microstrip antenna. Microstrip antenna has different types of antennas such as patch antenna, slot antenna, and spiral antenna. seen about the patch antennas, let's see about the slot antenna and the spiral antenna. A microstrip antenna with a narrow slot cut in the ground plane which allows the radio waves to radiate. In the spiral antenna, the microstrip antenna with a spiral shaped conductor that creates a wide band impedance matching and allows for efficient radiation over a broad frequency range. Phased array antenna. Radiate system. There are different applications which is done by the phased array antenna. Radial system, satellite communication, mobile communication, and wireless networks. Phased array antenna are in a radial system to accurately track and identify the objects by transmitting and receiving the waves at a specific frequency. Satellite communication. They are also used in the satellite communication to improve the data rates and beamforming the capabilities and enabling the high bandwidth communication with multiple satellites. The phased antenna. We can see the different applications of the wireless communication system. Mobile antenna. Antennas play a crucial role in the mobile communication system, enabling the transmission and reception of voice and data signal. Distance between the mobiles and the base station. Satellite communication. The antennas are essential for transmitting and receiving the signals between the satellites and the around ground stations, enabling the communication over the vast distance. Radio broadcasting. Antennas are used to transmit the radio signals from the broadcasting stations to the receivers. Radar sense system. Antennas are used in the radar system to detect the track objects by transmitting and receiving the radio waves. Conclusion and future trends of the antennas. The antennas are essential components of the wireless communication system and are constantly evolving to meet the growing demand of the higher data rates, improved signal quality, and wider convergence. As the wireless technological advance can expect the see future development in innovations in antenna design, including the development of the new antenna types and the integration of the antenna with the other components to create more efficient and compact system. The future of the antennas is bright, with ongoing research focusing on the developing the antennas with improved performance, size, and increased integration capabilities. These advancements will continue to drive the development of new and innovative wireless communication technologies. Thank you for your precious time. Please do like, share, and subscribe.